I'm just gonna talk for, I don't know, like 10, 20 minutes and I'll edit like some out. But I've been watching that fucking YouTuber who does the portal videos, like concept of portals, and Jesus Christ, it's breaking my brain. Like, I don't. I'm trying to grasp the common thing where you put a portal here, and you put a portal, then you put a block here, and then you put a slanted one here, then you put another portal. Like, what's it gonna do, right? If this goes down. Logically, if it's a doorway, nothing happens. The block just stays there. The block just stays there, it does nothing. But if the doorway is in two, then it acts the same way as a doorway. The thing is, now this side moves, but this side stays put. It does not move. So what happens if something passes through? Something's here, and then, because these are flips at opposite ways, obviously. So once it goes through there, and because there's no such thing as before teleportation, after teleportation, because a sinusoidal one works the same as a flat one. Or it's so hard to explain. Logically, if it's the same thing, it goes past the boundary basically. Nothing. It should just stand there. But there's gravity now. There's gravity acting on it now. There's always gravity acting on it, because there's gravity in this situation, and because this does not move, technically, and because this comes to an abrupt stop, it should stop here, and then its gravitational reference frame will change, thus causing it to slide down instead of flying out. But if that's true, then in this homicidal thing, would this have a different gravity than this part? Like if it were to have there, or say, perchance, this way, and you simply rest a ball here, the ball would logically go there. But does gravity act on this part? Because if it acts on this part, it would also act on this part. And then I got to thinking, wait, there's no such thing as this doesn't exist. Between, if there's two doorways. Oh, right. Because this can be held bigger as it wants to be, or small as it wants to be. They both exist in the same reference frame at the same time. So, like, the main question. It breaks so many laws of physics to separate the doorway. Simply going one way and coming out another place is so goddamn complicated. Because the video posed the idea that if you had a rotating portal and you had like a square here, so it rotated, what would happen here? And one of the solutions was it just carries on that way. Another one is where it continues the same trajectory from the same one. As it would be the same as having a elongated one because of its angle of rotation. And it would satisfy both scenario. It would produce a result effectively the same because it never teleported. But then the space between here and here also is no difference because it can be as big as it wants. Then if it could just be bigger and also include that space. So if you had a box with 2 portals with a, let's say, a purple and a black side, because for some reason I'm using purple, then everywhere is simultaneously in the portal and not in the portal. There's no such thing as in the portal, and there's no such thing as outside the portal. And let's just say they're statically locked at the moment. And theoretically, as these will define a shape, it looks, if I remember correctly, I remember it being something like this. Where if you were to cut holes here, and you would piece them together to make like a cone shape, and glue them together. That's the sort of shape it would make. But if this whole wall was a portal, and for convenience sake, let's say this is actually the other side of the portal, but it's just symbolizing a portal there, then this whole room would be a cylinder, because it's more simple. So imagine right now, where the portal line would be a river, and you're simply just going around in a circle. That makes sense. How are you gonna move it off the wall? You would have to make another portal. But then it wouldn't be this. So that's dumb. What am I thinking? Wait. No, what did it approach 0? Or approach 1 or something like that? Where there's actually a small circle here. Oh, it would do, wouldn't it? If you were to move this portal off the wall, it would enlarge this circle. The circle would become bigger and bigger. And if you shrink the size, you'll shrink that size. Oh, look at them talk about topology now. Oh. Wait. Topologically, this would be a 4-dimensional cube, no, 4-dimensional torus. Like how a 1-dimensional strip of paper becomes 2-dimensional. No, 2-dimensional becomes 3-dimensional. My bad. Something. It's a strip of paper that, if you twist it, it becomes itself. Same side. Or you turn this side. There we go. It becomes, it's only a sheet of paper, but the break is here. And you simply go from this side. Okay. Now I'm just confusing myself. How the hell am I going to edit this? I'm getting a cramp. Oh, there you go. Done. Obviously, this breaks the laws of physics. And you technically can only move a portal by a Planck's length at a time. It's as small as you could move a portal. and it's the smallest unit you could move something, so it makes sense. And the case of I'm just going to explore ideas I have now. The case of having a portal as a smaller portal, it's basically just water diffraction. You can things, well, I can become bigger as they're in the water, but if you put your hand in, it also become bigger. But it's the same size. Would this appear darker? And this brighter? I mean, logically speaking, this one has less light and this one has more light. No, this one has less light, this one has more light. Like how a powerful torch can seem like the brightest thing, but like an overcast seems like well, the inverse square law, whatever. Like half the distance 4 times, or the twice the distance 4 times the squared the fall off. Couldn't, right, because also light would behave so differently in portals, because it works the same with mirrors as well. Mirrors are just anti-portals. They just reflect. They're just portal on a portal. But you can't go through it because you're touching the stuff. So in portals, not portals, mirrors, the further you look into a mirror, the darker it gets. And I'm pretty sure there's a blue shift. Because it goes green. No, mirrors are green, my bad. There would be a blue shift though. No, it'd be a red shift. Would it be a red shift? If you're moving. Yeah. Further into a mirror or portal you get, or more reflections you get, if you were to move, the light would take longer to get to you. So there would be a blue shift, where the light would do some Doppler effect, same way sound does. God, how would sound work? I'm not gonna get into that. I want to get into that. Okay. I guess sound wasn't bouncing off anything. Like if you shoot through a doorway, it goes in, hits that, does whatever it does, you know, the usual. But then it would go here, go here, go here, and then come out here again. I guess air would dampen it, but you're like getting like an instant echo. Not instant, but like echo that would be way less damaging. Like you can hear stuff from far away. It would take a long time. And the waves that would happen, where this would be way louder. Oh, the amplification. Like if you set it like a 1 Hz semitone through there, would it amplify for ages? Like if you sit there for like a second, it gets through there again. It just keeps layering. I guess that would be a little bit off, so they sort of cancel out. But there should be some amplification there. Okay. Right. Portals. Having a portal at itself, like if you imagine a mirror is just a portal stacked on itself, then separating that, you would just meet in the middle, would you not? If you stuck your hand in, it would come out here and you'd meet here. and it would be like a mirror. And if you would move that, the middle would move. Yeah, and the shadow would get shorter. Like, you could hold it. Wait. What if you were to hold your hand here? No, you can't hold. You can't go past the middle. Yeah, you would stop yourself. These aren't actually same size. What if you turned it? So, like, okay. So now, if this is the top. Oh, this is the top. I did it wrong. There we go. So now if you put your hand in, they'll be mirrored. Because they do a 180-degree rotation. So now, if you put your hand in, you could theoretically shake your own hand. You could put your hand in here, it would come out here, you meet in the middle. But instead of going right, yeah, if you go around here, it would come around here. That would make sense. Again, not even thinking. I did not watch all the way through. I watched like the first 5. Right! That's why I was talking about gravity. Now I remember. Back to this one. Gravitational reference frame. Here. You have a portal here. You have a portal here. This is Earth. That one's never on the map. Whoa. It's Earth. Blah blah blah. Everyone here, you go in here. You come out here. They started as the same. They started the same way up. The same way up. You simply somehow moved it there. You didn't go around. You just magically teleported. So you're in the same orientation, dimensionally, at a global universal scale. This is always up, even though there is no up in space. You're standing by and just keeping the same reference frame. Ignoring gravity and using the sun. So if you came in this way, you would appear upside down the other way. You would appear at the bottom in the same rotation. Thus, it only matters on your reference frame. Going in here, even if it's same rotation. Oh no, God, I don't remember why I didn't do this. Gravity's complicated. What law of physics does this break? Conservation of energy? Okay, now I remember why I was talking about this. If you go in here, come out here, you're this way up, and you come out this way up. Relatively speaking, you're upside down. If we rotate it, you're upside down. You came in upside down, you're upside down. Now if you walk around, you're gonna be the wrong way up. Your head will be to the ground. Theoretically. Very theoretically. I mean, portals are theoretic here. Oh, I have an idea. Since gravity, the force, technically not a force, just the bending of space-time, is technically also following the inverse square law, then near a... oh, it's way too big. Then near a portal, wouldn't there... if a portal like this and a portal like that, if you go in this way, you come out that way. This way. Come in that way, you came out that way. Color coded actually. Ooh. Boom. Boom. You come in the purple side, you come out the purple side. Pretend these are flat and it don't exist. The end of it doesn't exist, which makes no logical sense, but let's go with it. Then, technically, if the ground is here, there's a gravitational force this way, and gravitational force this way. We would rotate this. It's the same reference point, technically. Rotational. Gravity affects you how far away you are from it. And technically, this and this occupy the same space. About two real superpositions, I guess, would be the right word for it. How long have I gone on for, actually? 30 minutes. I can edit it down. Yeah, you're in a superposition, basically. They exist at the same point. They both exist at the same point at two different points in time. Two different points in space at the same time. Yeah. So, do I explain spinning space-time? Big well, planet, you drop in there, you go towards it because of hill. Yeah, there you go, that's all you need to know. Hill. You go and become less curve at exponential rate. Or logarithmic if you're going the other way. So, technically everything's going that way. Everything's going that way. Big well going that way. And there's a... Okay. That means... big well going this way. That means the well also comes out here. But it decreases. Because there is another bending the space-time going this way again. So there'll be a space-time vector. There'll be a force this way, and a similar force this way, and the force will go that way. So if we come back to this, there's a force down this way, which is that way. So there is a force coming out here, but there's also a force going down here. That means the force is this way, meaning it will go that way, and then curve off at a logarithmic rate. It wouldn't follow parabola. It would follow this, where this would be approaching a number but never reach it. Okay, I think I got the main point I was going for. This does not exist. It's a good explanation for it, and a surface can be whatever it wants. But all it is just an explanation for what shape it takes. Doesn't matter if this is like weird, a weird shape, but it always connects, basically. So, now the main point I was getting is if you move the portals, you are fucking the space-time. Holy shit. You are missing and just bending the fabric of space. I mean, that happens with, if you really think about it, it's happened when you move a ball, this gravity will influence it and sort of just move the well, I guess. It makes that way. Without gravity, it would work exactly how it describes it. Yeah, this example, it would turn. Now, would it actually? Let me think about this more. Right. Okay. If this can take whatever shape it wants, then the shape doesn't move at all. Just your perception of it moves. It's not moving in space or time. It's just the light that's hitting it is changing where it's hitting from. Like a mirror. Exactly like a mirror, actually. The image is not the shape when you hold a mirror up. When you hold a mirror up like this, and you see there's a ball there, you're looking at it. The shape's not here. It's here. It's always been here. It never moved. You can look at this one too. But there's a wall. There's a wall. You can't see it. It's still there. Even if you see it here. There's just a wall in the way. Now, I don't think the shape of a portal can change. Well, it can. No, it can. Topple. You know the word. The straw hole conundrum. That sort of field of science. That way, yes, it can change. But if you had a portal, I don't think you could change the shape of it. Why do I think this? I'll get back to you in a second. For simplicity, I don't think we should accept the fact that a portal can change shape freely. I think once a shape of portals is defined, I don't think we should change it. No, it should act the same, but I don't think we should actually treat it as the same. We can treat it as a different shape for simplicity, like how we can treat a hole in the ground the same as a cup in that field. But we don't treat these the same. We don't think we can actually grab the side of this. So with a flat, I don't think any portal. It has a surface. It's never flat. It has a surface. No matter how nuanced or curved that surface is, it always has a surface. Actually, no. This example's stupid. I meant to use a plate. Pretend this is a plate. Look, here's a spoon. It's a plate. So then, yes, you can actually grab the side of it, but then this, if you put a ball here and a ball here, basically the same space. If you look at it from above, and you would see the ball, but here you would not see the ball because it's obstructed. God, these look like psychotic drawings. Yeah. Oh, I just thought of some. What? Okay. Okay, if you were to twist the portal, you'd be able to go through it. You'd be able to swap sides. And everything would be upside down. Meaning there'll be gravitational influence. Okay. the nearer you got to, okay, pretend this is the flip. This is the flip one. This is the black side on that one. So if you go, you just go through like a doorway. I could have done that actually. Okay. Yeah, if these are flips, you smash them together. Okay. That topology. Topolog. I can still not say that word. And then, okay. And because of gravity going always this way in this reference frame, because it's the biggest object is Earth, then there would be gravity this way and gravity this way. So at some point, there'll be zero gravity here, like over here, where you just float something. And the nearer you got to it, the more it would do that. It would be here, it would be like that. Yeah. It would be a tan curve with a logarithmic end on each side. Oh, technically it would just be, yeah, it'd just be a logarithmic end on each side. But really it's just a parabola. What is it? A sine? It's a sine curve. God damn it. It's just a sine curve. Okay. Obviously there'll be air resistance. The air would move fucked up. Yeah. In other words, don't put the portal near Jupiter. Or any other big global object too close to it anyway. As if you were to put it, let's say, near the core of Jupiter. Everything would be crushed next to the other side of the portal. It would all funnel into there. Okay, I think we should stop thinking of these as doorways. And more like, which one is it? Yeah, more like wormholes. Where you just move. I'm sure I'll spend way too long going through Blender and give up halfway and you won't see anything I'm talking about. I'm sure that would happen. I could make a new layer. I'm an idiot. Oh, it's so much easier. Actually, I should fill this in with white. Bonk, 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 bonk. There we go. Bonk, there we go. As background. Help me. Okay. What did I look about? Right. Why I thought moving portals wouldn't be possible. Right. How wrong I was. Right. Okay, let's talk about moving portals, I guess. And again, I'm gonna repeat this for simplicity's sake. I'm not saying portals can change shape. They can't change shape. Once they have a shape, they cannot change. In this scenario, just like when you say the ice does not have friction when dealing with motion, it's just for simplicity. Of course they can change shape. The Easter Bunny's real and there's a Queen of England. Actually there's not anymore. Don't worry about that. Okay. How to deal with moving portals. Space-time, big sheet of paper. Big, huge sheet of paper. We have no idea if it's a torus, if it's a sphere, blah blah blah. We have no idea. It could be octagon, it could be hexagon. Who knows? It could be a dodecahedron. Or basically big sheet of paper. Big sheet of paper. In this example. Now if we were to make, I don't know, a portal here and a portal here, simple as. We just go bing bang boom, join these two together, and we have something fucked up that looks like no, I'm rubbing out the white, I'm drawing on the background. You have something fucked up. Wrong color. There's something fucked up. No, I'll never get this size again. No. Oh well. It looks like the. Oh, God, I ignore that. It looks like this. Wow, that's fucked up. Look how much we fucked up space-time. I guess that would go like that. I don't know. Because you can travel between them, and you would travel between them forever. I don't want to think how you would turn them around. Let's not worry about that for now. Just pretend it looks like that. I'm sure I just got the dimensions wrong here. Okay. Look at that. Wow. Wowie. Wrong one. Wow. Wowie, look at that. So cool. Wow, what was I on about? Right, it would look like this. Wow. You go through here, you go from the outside to the inside. Wow. You just travel this. And if you go from the outside to the inside, you just travel around a corner. Wow. I'm sure it looks like this is connecting and like this is connecting. Like some point. Same with these ones. These probably join here. I did not draw it right. Because you can go around it. Like you should be able to travel that length. But you get the point. You get the point. It's just, yeah. Okay. Okay. So moving portals. If you were to move this, you would move everything in here. Everything. Everything in there would move. If you were between portals, if you were in this band, and it moves this way, everything here is moving. Everything in here is moving. That means, and if we go back to this, and here, and over here, it is moving. These two are connected. But it would only move in the ways it was moved. It would simply do a rotation, come out the back, and be here again. Staying still. I repeat, it did not move. The portals moved, which change were received in space-time. Okay. It would do a full loop, come out the back, and do that. Now, if you were to touch it, or do anything else, you would simply be moving it through space-time like that. If you moved it out of the portal's way, you'll simply move from in here to out here. It's all you're doing. Where it will be no longer influenced by the portal. By moving it. But if you move the portal back, I don't know, let's say you move the portal here, and move the ball there, and then you somehow yank the portal, you'll simply be moving the loop back where the circle was. Okay, I think I figured this shit out. You're simply moving where the curvature is. or the precede curvature. This would be a four-dimensional point in space. But then the sheet, 2D sheet, is a three-dimensional plane, and any curves or any movements or back and forth is simply four-dimensional movement. Okay. Makes sense? It shouldn't. This shouldn't make any sense. I think I figured it out. So, with a portal, there's no such thing as this. Oh, there is. This is how it's shaped. But it does act the same. That's why it acts the same. But I don't... This example, again, is to say it stays the same thing. It simply goes through it and stays. Okay. I think that's all I think I figured out for today. It's out of my system. I can go back to having a normal life. Until the next one comes out, I guess. I hope it's not any worse than what I've explained here. I am not saving these. Screw you. Fuck off.